Thanks everyone for joining in. Let's wait for one more minute and then we get started. I would please request the non-speakers to mute themselves so that we have a clean recording. And once we upload it on our YouTube channel, you can tune in later as well. Thank you. Okay, I think we can get started now. Welcome everyone. This is Gaurav speaking from Bangalore, and this is our July episode for SAP BTP Garage. I would really thank you for you to joining in again. For the first timers, the whole idea for SAP BTP Garage is to bring out key use cases on a regular monthly basis. And these use cases are built on top of BTP, leveraging SAP BTP services. And these use cases are also developed by the great minds and hands behind these use case. And just like today, we are also featuring this key use case where we are developing a multi-tenant SaaS applications on BTP. And the runtime that we would be showcasing today is the Kyma runtime. This is the second episode to the series of uh, use cases that we have published. The previous one was on Cloud Foundry runtime, and today's session is on the Kyma runtime. And I'm being joined by my colleague Cecily. She's the global host for SAP BTP Garage. And also, as I mentioned, the minds and brains and the hands behind this key use case, Ajit and Alpa, who are the experts who have created this use case and are now enabling the partners, customers, and citizen developers to build such a solution. So again, great thanks to Ajit and Alapa for taking out time to feature this use case, and also a great thanks to you who have made our SAP BTP Garage a huge success over the past years and months. So please keep that support coming in, and also let us know what all sessions you would want to see in the next Garage as well. Uh, just like SAP BTP Garage, we also have some more hands-on and in-person enablement opportunities. So if you are a partner who is based out of any of these regions, or let's say close to these regions, feel free to join in these hands-on and in-person workshops, or let's say multiply it with your colleagues so that they can join in and then you can cross learn from them. These are the list of workshops that we are rolling out on the lines of integration suite, business AI as of now. We would be sharing the links on you to register, so feel free to do that part. Before I hand over to Ajit and Alpa, I just wanted to let you know that in our next SAP BTP Garage in the month of August, we would be showcasing how you as a partner or a customer can unlock your Signavio process insights and integrate it with build process automation. So this is for the August series, but for today, I would let Ajit and Alpa talk about this use case on building SaaS solutions on BTP Kyma runtime. Ajit, Alpa, over to you.
Thank you, Gaurav.
Thanks, Gaurav.
Let me start with sharing my screen first. Gaurav, can you confirm that you can see my screen?
Yep, I can see.
All right. Thanks everyone for joining this session today. My name is Ajit Kumar Panna and I'm here with my colleague Alper. We both belong to platform architecture and adoption team and part of office of CTO. We both work as cloud architects in SAP Labs. In today's session, we will focus on building a multi-tenant application on SAP BTP. In previous session, we had talked about basics about multi-tenancy, how does it work on SAP BTP and what's the architecture look like Cloud Foundry, and we also had showed a short demo as well. So in today's session, I will just go through the basics and of the multi-tenant application very quickly. For a detailed one, you can refer to the old recorded video that's available on YouTube, right? However, in later part of the session today, I will focus on the Kyma architecture and what's the difference in terms of different tooling, development and deployment strategies, or what are the services that are there to help you, or tools that are there to help you build a multi-tenant application on Kyma especially. Then towards the end, we will show a demo as well. The application is same, but I will show the system today because it happens that many of us haven't seen the Kyma platform. How does it look like, and how things are connected, etc. So towards the end, I will jump into the system and show some code and run some APIs and etc. And we'll show you how the sample application looks like, right? So let's begin with the basics, right? Typically, what happens is when customers, go through their digital transformation and use different cloud platforms, especially SAP BTP. They start creating this sub accounts for different region-based teams, and they start to develop applications. So in turn, what happens is the different teams build similar applications in each of these sub accounts. So which leads to unnecessary cost, and even though the requirements are similar, they have multiple applications running in different sub accounts. So this is where the multi-tenant application concept can help, along with the SAP's recommended programming model, cloud application programming model in short CAP. And this is not just for customers; it can help partners as well to build application and sell it to their customer using this multi-tenant concept, right? So basically, multi-tenancy is basically an architecture pattern where a single instance of application is being served or being used by multiple customers. So if you look at the diagram in single tenant, you are deploying the application and I set up for each customer separately. In case of multi-tenant, you have a single application which is being used by multiple customer. In some cases, these customers or the consumers are called tenants, and hence the name multi-tenant application as well, right? And what it means by this running a single application is that the application is physically integrated. Means you are running the application once in one sub account. However, it is being consumed by different customer, and each of these customers are logically separated. Their different data, the configurations related to that particular customer are completely logically separated, right? So essentially, this is multi-tenancy is an architecture pattern used to build SaaS application, and in next few minutes, we will see how to build such an application using this concept in SAP BTP, right? So what are the benefits? One thing is, because the resources, the backing services, etc., are being shared among different customers, right? Because you're running a single application, so the sharing of resource leads to the reduced cost, and it also helps in improved scalability. For example, if you take HANA Cloud, on SAP BTP, you could use the same instance for multiple customers, okay? And the data is completely separated. As and when required, you can just scale up or scale up the HANA resource, which basically means you are using the HANA Cloud resource effectively, right? If you had to deploy the same application to different customers separately, you would have created in custom sub accounts on one HANA Cloud instance, which would have increased the cost as well, right? And it has other benefits such as easier maintenance and simplified upgrade, because you have a single code base and infra. If you find a bug, you are fixing once and it is fixed for all the customers. And in similar fashion, when you release a feature or upgrade your application, it is done for all the customers or consumers, right? Now, it definitely comes with certain challenges as per se. For example, because you're running one instance and being used by multiple customers, you have to make sure that it is always available, and you have to ensure that the multi-tenancy or the logical separation of data and configuration is taken care, which could lead to the increased complexity of the application. Also, this provides a bit of less flexibility that you may have in single tenant applications, because you're kind of dealing with one fits all approach, where these features are for all the consumers. However, that doesn't mean you cannot extend certain things for particular consumers. It's also possible to do that as well. The other challenges that you can face in multi-tenant application is this regulatory challenges, where you are serving different customer from different regions or different countries. They might have different security and regulatory requirements, which could make your application design a bit complex and challenging to design as well. And in similar fashion, it could increase the integration efforts as well, because different customers will have different integration strategy and requirements. Right? Now, how all this fits into the SAP BTP. So when we're talking about building multi-tenant application on SAP BTP, typically two roles are involved. First one is application provider, where you act as you basically design and develop the application and operate it on SAP BTP. Whatever the backing services that is being consumed in the application, for those services, as an application provider, you will pay for it, right? And the sub account that you're deploying, it's typically called provider sub account. However, there is no technical distinction. It is just a functional distinction that the sub account where your application is running is basically a provider sub account. Then you can create other sub accounts for different customers or consumers, and that's typically called consumer sub account. And this is where you can subscribe to the application. If you have used SAP BTP before, you might have subscribed to SAP Integration Suite or some other applications where you subscribe to application, you get an instance of that application and you start using that, right? In similar fashion, your application can be subscribed from the consumer sub account, and at the end you get an URL, dedicated URL, and start using it by your customers or your users, right? So the user experience in terms of subscribing the application remains same that you see from standard SAP BTP services like Integration Suite, etc. Right? Now let's understand a bit more detailed how all these things work, right? How these sub accounts look like, what are the overall account structure look like. So the global account setup is managed by the application provider who builds the application, runs and operates and maintains it, right? And your multi-tenant business application is running in the provider sub account. It can use all the services available on SAP BTP. However, to make multi-tenant, you will need few of the mandatory services, or you will end up using for sure, right? The first one is SaaS provisioning service instance. This service handles the subscription lifecycle of your application. For example, when you subscribe the multi-tenant application from consumer sub account, what should happen, etc., how the flow should come to your application, etc., is being handled when you subscribe or even unsubscribe. How that life cycle looks like, how the life cycle is handled behind the scene is taken care by this service instance. So basically, we'll build your application and we will register your application into this service. Now, similarly, we will also need the XSUI service instance, which helps us in handling authentication and authorization part of it, because we are trying to have the SaaS experience where the authorization is handled by the customers itself from consumer sub account, which means the authorization checks should happen with respect to the consumer sub account, not where the your multi-tenant application is running, which is provider sub account, right? So this cross sub account authorization check is being handled by the accessory service instance because it is multi-tenant aware in service. The third part is you can you will use a standalone app router, which helps us basically to achieve this multi-tenancy concept, or in other simpler terms, that it helps you to identify the customer or the consumer or the tenant that is the request is coming from. As I said, each of the subscription from consumer sub account will lead to a different URL, and based on that URL, this application router can identify which is the tenant the request is coming from, accordingly handle this logical separation of the data and configuration, etc. Right? So it helps in achieving this multi-tenancy concept. Now coming to the data separation part, this I've talked in earlier or the previous session as well. There are three ways you can do data separation. One is column discriminator, where you are keeping a column tenant ID in each of your table, and using that to kind of segregating the data when the request comes from user or APIs, etc. The second approach is you have a separate DB for each of these tenants, okay, but this would lead to the increased cost because you are using a separate database for each of these customer. However, this provides complete data separation, or the the most secure option we have, but it is not preferred because it increases the cost a lot. Now, what is recommended from SAP side, or from SAP BTP perspective, is that you could use HANA Cloud, and which has this HDI container which separates the schemas completely, and each of these schemas or the HDI containers can be used for dedicated customer, which kind of helps us to have complete separation of data. And we're talking about using CAP as a programming model, and this natively supports or handles have a tighter integration to the SAP HANA Cloud, and SAP BTP has other services which helps us to achieve this kind of data separation and the provisioning of this SDI containers, etc. Right. So this is basically the recommended approach, where we are creating separate SDI containers for each of these customers. Now, just a quick recap how the single tenant and multi-tenant application flow looks like. This may not be the complete diagram, just I'm putting it just to explain how things work, or what's the difference in terms of single tenant and multi-tenant application. In single tenant, what happens is when user accesses the application, the request comes to application URL, and using access US service, the user gets authenticated, and then the request, depending on the request, it could load the UI or the user interface from the HTML5 application repository, or if it's a data call or API call, which can be forwarded to the CAP application. And this is where the authorization checks happens, and it loads the data from the HANA Cloud HDI container. It can also connect to the S4HANA system or any other SAP system and third-party system to bring data and present to the user. So this is the typical flow of single tenant application. So in multi-tenant, the experience is a little different from development and deployment perspective, how things work in behind the scene, but from user perspective, the end user will not realize the change, right? So as a application consumer, first is, of course, you will subscribe to the your multi-tenant application. That happens through SaaS registry, and when you subscribe, the request comes to your business application or your CAP application, which has a service, or which has an integration to the service called Service Manager, which handles this HDI container provisioning part. So there is a dedicated HDI container for each of the customer when they subscribe. The handling of this HDI container is managed by the service manager. And note that this is automatically taken care from development perspective. We just need to configure properly some settings, but no coding required. There are tools to do that as well. Now, how the user access look like, how the flow look like. Based on this dedicated URL for the consumer, user tries to use that URL which sends the request to the application router in similar fashion, and the application router uses the XSS service to authenticate the user. And this is where it can go to the consumer sub account and get the assigned roles, etc. details, and store it in the token and forward the request to a required application or service. Right. In case of interface UI, it will same. It will go to the HTML5 application repository. If it is a API or OData call, it will forward the request to the CAP application. And this is where application router plays a role of identifying the tenant, which consumer it is, and have that information in the request itself, so that CAP application along with service manager can identify the tenant container and accordingly loads the data. In similar fashion, it can go to the destination that is created in consumer sub account and get the details either from SAP system or even non-SAP system. Right. So now coming to the different tools and services that SAP BTP and CAP offers, we have different services which are multi-tenant aware or multi-tenant enabled, which helps us to have helps us to achieve this multi-tenant concept, right? HANA Cloud and destination service, access to service, SaaS provisioning service. These services are available on SAP BTP. And coming to the environment, you can use all three environment to have this multi-tenant application. Of course, there are certain guidelines, or based on the application design and requirement, you could use different environment. Today, we'll focus a bit on Kyma, how the application look like, and what all tools are there as well, right? In terms of app out-of-the-box features, it has a lot of integrations with SAP BTP services, destination connectivity. If you have used single tenant application as well, some of the services you have seen, like how easy it is to integrate to BTP services using cloud application program model. In addition to that, this has a tool or a package MTXS multi-tenancy tools, which helps you to build multi-tenant applications. Not only that, it helps in locally testing this multi-tenant concept and adding some feature toggles or extensibility, etc. Right. Now, before I jump into the architecture itself, I just wanted to touch base few of the differences or similarities that we have between Cloud Foundry and Kyma. I will not go into details, but I will just touch upon the important points so that we understand, or when I take some names, so that you understand what I'm talking about, right? So the definition itself, like Cloud Foundry is basically a PaaS offering that helps you to rapidly deploy applications, right? And the Cloud Foundry environment is designed, to provide a simplified experience for the developer, right? And which essentially means it prioritizes simplicity, and the speed of deployment is faster. Basically, this platform is designed so that time to market is shorter, right? However, the Kyma environment, it's a fully managed Kubernetes runtime that helps you to deploy containerized applications, right? This has the flexibility and control that you might need in designing application certain cases where you need access to the infrastructure, you want to control how things work within the application, etc. However, in terms of Cloud Foundry, you are giving that control to the Cloud Foundry that which takes care of by itself. So Cloud Foundry abstracts you from this infrastructure details, how behind the scene the containerization works, etc. Right? Which in turn, it makes it easy for developers, but it provides a little bit of limited flexibility, right? And in case of Cloud Foundry, you have this concept called build pack, which automatically identify what kind of application type is, whether it's a Node.js application or Java application, etc. Right, and provides you this or builds the container by itself, providing the runtime that is required for your application. However, in terms of Kyma, you have this flexibility to containerize your application by yourself, right? Which means you have more control in this case, but in some case to reduce the entry barrier, or to help you to avoid some pitfalls like security sets, etc. In this case also, SAP provides different official images to use, or there are different Paketo build packs that you could use as well to containerize your application, right? But if you want, you can still do on your own as well, right? Now, coming to the deployment part, the difference is basically the object that gets generated at the end and how you are doing it, the deployment. But in both cases, SAP has provided different tools, or the community has already such few tools which helps you to increase the speed of deployment. However, in case of Kyma, you have again much more control how the deployment works, how the objects are getting created, etc. You can control in much more. You can talk to the infrastructure basically, and figure out how things should look like and how it works. Right. Coming to the tool for deployment, in case of CF, you have this MTACF plugin which helps you to deploy your application using a deployment descriptor mta.yaml file, where you are describing your application and the dependent resources that is needed from SAP BTP side, right? You can define it and use it for deployment. In similar fashion, from Kyma side, you have something called Helm. It's a package manager which helps you to deploy your application and dependent sources on Kyma. At the end, basically, it creates all this Kyma resource manifest that I'll show you in a bit, and it tries to deploy onto the platform. And this Helm in this Helm world, basically applications are represented as charts, or you can have subcharts and templates, etc., to help you simplify the deployment process. So, in terms of development and deployment, the differences is using in tools and understanding. Okay, Kyma provides a little more flexibility. However, your CAP application, it doesn't have any impact, which means you could run both on Cloud Foundry and Kyma. It's just that CAP itself has different built-in commands to help you this generating this MTA deployment descriptor or the Helm charts itself for deploying on Kyma. However, you can Kyma's case, you can customize these charts, and you can make sure the deployment or the design happens according to your choice. The one of the key difference is how the service consumption look like from application perspective. It doesn't change much. It's just that how the from your platform perspective, how these things the services are consumed changes a bit. For example, in Cloud Foundry, BTP has the service brokers which is being used to manage this life cycle of the service itself. Like when you deploy your application, the service gets created, or when you undeploy, it gets deleted. That's handled by service broker. And when you bind those services to your application, the credentials are getting stored in the or the credentials are delegated to a VCAP services environment variable, which is again being used by the CAP application. In similar fashion, the service lifecycle is managed by BTP service operators, which is which you can enable in the Kyma and use it to kind of handle the service management part. And when you create a binding, it basically creates a Kubernetes secret or Kyma secret, which is attached to your application as a volume mount, right? And then your application uses those secrets to communicate with the services or applications. If you want to consume from any APIs or services from hyperscaler perspective, you could create user-provided services on Cloud Foundry, and the rest of the binding to your application remains same. However, the lifecycle of the service itself is managed outside of BTP or whichever hyperscaler you are using. It remains in that platform. Coming to the Kyma side, there are different Kubernetes operators provided by these hyperscaler, which you could install into the Kyma and have lifecycle managed from the Kyma itself, when you deploy your application. But the consumption remains the same, where a Kubernetes secret is getting created and it's mounted to the application, right? And I've already mentioned about the extensive part. Cloud Foundry provides limited amount of extensibility. However, Kyma, because you have the access to your underlying infrastructure, you could control much more in detail, and you could see or deploy according to your design, application design, right? So to summarize, that having a multi-tenant application both on Cloud Foundry Kyma is basically similar, because the concept itself is abstracted from the runtime. Only difference is the containerization, security, and deployment, etc. This is here again, SAP BTP and CAP offers a lot of tools to help you that, creating these charts or the MTA file, etc. The tools are available to use to make it simplified. However, the overall architecture remains same. The touch points of those applications in terms of platform resources or the objects that you have in different platforms, the touch points are different. For example, in case of Cloud Foundry, the first entry point is Cloud Foundry routes. In case of Kyma, it's API rules, or the gateway itself is to gateway itself. So the touch points are different, but overall architecture remains same. So now to summarize, between Cloud Foundry and Kyma, Cloud Foundry, when you try to deploy your CAP application, you're simply telling, run this for me, please. I don't care how. Basically, Cloud Foundry takes care of making the containerization and deploying and running and everything, right? Networking, scaling, etc. In case of Kyma, you are telling exactly how precisely it should run and how it should look like, right? So you have much more control. So that's the distinction between Cloud Foundry and Kyma when you're talking about app application and multi-tenant application. Right. Now let's look at the architecture itself. This architecture I've talked about a bit in last session. So I'll just jump to the Kyma architecture. So the overall architecture remains same. You have your business application, which is multi-tenant application, and you're using SaaS registry to register your application, and you can subscribe to it. In addition, you can have this SaaS API service, which is again a multi-tenant API service, which could fetch data from the customer specific container, etc. Right? So the idea is to have a API based communication, not just from the user interface or from business point of view. You could have the API details where you are either pulling data or pushing data into your business application or multi-tenant application, right? And for this API to have, you need a API broker, which is again registered to different consumer sub account. This is needed to give you a similar experience that you that your users have when they subscribe to a service instance or BTP services that are provided by SAP itself, right? To provide that similar experience where you're creating a service instance and creating a key and then pulling or pushing or using those APIs uh, to achieve some functionality, right? To have the similar functionality, you need this broker. In addition to that, you could use similar to Cloud Foundry architecture, you could use a third party or sorry, the cloud identity service from SAP, right? You could use it to maintain your users and integrate it to your multi-application. That is also possible, right? The overall flow, it remains same. The user accesses and based on the tenant identifier, it forwards the request and it fetches the data from the SDA container created for that customer, right? So this is where I would like to just jump into the our repo uh, just to show quickly that what we have in our repo. So our repo has both Cloud Foundry and Kyma, based environment based architecture and the sample code. But the application is divided into three different versions: basic, advanced, and expert level. Basic version you could deploy to a trial account even and see how things work. Advanced version talks about different advanced topics, right? Using API management, etc., which we will see today in a few minutes, right? So it is not just that it just gives you the code base. It explains everything in detail. How does the Helm chart look like? What are the resources gets created behind the scene? How the details look like? Let me just quickly open the behind the scene. The on the Kyma platform, what all resource gets created when you deploy our simple applications. It talks about in detail, right? And with this, I will now jump into the code and show you some of the details so that you are so that you are aware how things work a bit as well when you go from this session. So as I mentioned, for Kyma, you have this Helm charts. Okay, so the charts have different subcharts and templates. Okay, which essentially helps you to create this Kyma resource manifest. So simply, if I show you how it looks like, so I'm just using certain Helm commands to generate, the resource manifests. Now this generates this file. If you look at this file, right, all these YAML files are nothing but a resource on Kyma side, either network policy and different the pods, the deployment, the pod distribution budget and everything. It gets created. However, as a developer, there are tools provided from the app side where you can build or generate these charts according to your application design and provide some values to it. So at the end, probably you will be creating this values.yaml file where you are providing certain information like, okay, where is your application? What is the image for that? And from where you are fetching this image. And if it is a private registry, what is the image pool secret? Have you, you can maintain that in Kyma and use that to pull from your private registry as well, right? And what are the dependent services? And if any of your application requires different parameters, the configuration parameters, you can provide as well in this values.yaml file. So essentially, what it means, like charts have these templatized manifests where you are providing additional values to these parameters that's there in these templates and charts, and you are making sure all these things worked together, right? However, if you want to change in certain charts, how the deployment looks like, or if you want to modify the deployment object itself, you can go to those templates or charts specific to your application and change it accordingly as well. Right. So for today, I've already built this application. So for building, you need different build packs. The packet of build packs are in the different official images. You could build your application. The application images are pushed to certain repository. In our case, I pushed to Docker Hub, and I've created this Helm charts and pushed some images and deployed the applications already. So what I will do now is I will just jump into the account, and this is where I've enabled the Kyma environment, and I've created a namespace for these applications. Namespaces are basically like a folder in Kyma. Where you are separating your different resources as per your requirement, using these namespaces. Right. So I'll just quickly jump into the namespace and show you certain objects, just so that you get a feeling how it looks like. Yeah. So these are the different Kyma resources that you can see, and here probably would have heard before, like pods, and this is where your application is running at the end. However, the communication to the outside world happens through different other objects. If I just have to show you how certain connections are and how the objects are related, maybe I'll just jump into the API rule. This is the entry point of your application, or the endpoint that from a user is interacting from outside. So So if you look at the resource graph, this is how different objects are, connected. You have API rule where you have virtual service, authorization policy, which kind of validates, whether the security of those routes, and then it forwards the request to your service, which sends the request to pod, and in pod is basically mounted with different secrets. In our case, these are SAP BTP service instance bindings, where it is mounted as secrets, and it is also presents how which service instance and binding are connected to these secrets. And from deployment perspective, you could have different replica set and deployment, where you are defining how the deployment looks like, and how the pod auto scaling should happen. That's defined in horizontal pod autoscaler, etc. So all these objects are created when you deploy your chat. Now, from user experience perspective, uh, it remains the same. I've created this consumer specific account, and my application is deployed in this CIUS 20, which is basically the provider sub account. And I've deployed the application. You could see the different instances that gets created as part of the deployment as well. Right, so these are the different instances gets created on deployment. Now I will just quickly subscribe to the application. So this is our SaaS application, or the sample application that I've deployed, and you could choose a plan. That's again, it's a configuration given in the Helm chat. Accordingly, this configuration is being set up. So during the subscription, as I mentioned, the HDI container in the HANA Cloud instance gets created. If required, you can add your custom logic to provide certain additional functionality. as well. So I'll just wait for 1 minute. It should take 2 seconds to 1 minute. And then I will show you how the sample application look like. After that, we will also interact with the Multitenant API. I will create an instance of that as well and make some calls and push some data as well. All right. So it gets subscribed, right? And you could add your users as per choice, and you can assign roles if you have feature specific to your roles within your applications, like administrator or member, etc. You could assign different roles as well as part of your multi-tenant application. And for the user, it is just a single dedicated URL, and they could access and start using it, right? If you have cloud identity services integrated, you could have a different onboarding experience for the user, but the access of your applications remains same. This is how the sample application look like. Our sample application also has this in-app user experience where you could use customers or the consumers can create user and assign different roles from here as well, right? I'll just quickly show that, and you could use your multi-tenant specific roles as well. Then all right, let me just create a project so that I can show you how to push data into API by API project. I will just create one sample data. And if you see, there are no products available, right? And just to show you the demo, right, you can push some product from your third-party system or in SAP system. In our repo, we have a sample talking about how to push some data using the APIs and how to push from S4HANA itself, right? So what I will do is I will create a API instance, the service instance, and then I will create a key and use that to push some data. So here you can see the API service instance. Here I can have different plans as well. For example, you want to give different restrictions according to your plan, a different quota, and on the API request, number of API requests that you can make. You could have implemented such feature as well. All right, so now I will create a key basically and use that to push some data into the Multitenant application. And note that the data is specific to this consumer itself. Take this client ID. Client secret. URL. All right. So you probably have seen this API calls, or you have done this before in case of other service consumption as well. First, you get a access token, and make calls to your API that is there or provided as part of your multi-tenant application. So here I'm just making multiple calls to show you that you could have you can push some data into your multi-tenant application. So okay, the products I pushed successfully. So now let's check that quickly in our application. All right. See, now we're able to see the product details, which I could use. And this is how you could push some data or pull some data from your multi-tenant application using those APIs. Now, as I mentioned, you could have different plans for your API and accordingly restrict certain things. This is where we also have integrations to API management. How that looks like, where you could control different or you could apply different policies like quota, spike arrest, etc. That policies that are available on API management, you could use that, right? And this is where every request that your API gets routed to the API management, and in the API management, the policies are getting checked. Once the policies are validated, the request gets again forwarded to the your API multi-tenant API, and which basically presents the functionality to the user. We have a detailed explanation how this can be done. Okay, so I was planning to deploy and show it, but I've already deployed. Okay, in the interest of time, I will just show you how it works, etc. a bit. Okay. And then just show you what policy is there and how can you achieve that functionality. So basically, you could integrate your application to API management, and the integration happens, kind of via through virtual service. It's a object in on Kyma, where the routing is determined based on a header XJWT assertion. So when you send a API request, if you are not providing this header, right? So obviously, with this request, based on that missing header, it forwards the requests to the API management, right? And this is what you are defining in the virtual service, right? How it should route, right? And in the API management, you are applying all these policies. I will show you how these policies look like and how can you apply, etc. Right? And once you validate these applies, you forward with the header, with this JWT and header, and that you are creating the header every time using the access UI instance that is bound to your multi-tenant API application. So you are creating a token and binding it, adding it to the headers and sending it back to the Kyma. And the next time it checks, okay, the header is there, then it validates the header with the whether this header is there, and what's the issuer and what's the subject, who is the what's the request principal, etc. Using this objects request authentication and authorization policy, and then if it validates this successfully, then it forwards the request to your CAP based multi-tenant API, right? This is how the flow looks like. Okay, in our sample repo, we have a detailed description of how to set it up. Both, you could set it up manually, or you could just add certain parameters in the Helm chart, and the integration is done automatically. All you need to do is just set up the policies in integration suite API management capability. So I'll just quickly jump into the API management, and we'll show you how the policies are applied. So here I've created this API proxy, and this is where the request gets forwarded, and in the target endpoint, I'm forwarding back to the Kyma cluster, and I'm applying the policy. And these policies can be applied at different juncture of the flow. For example, in the pre-flow, first I'm decoding the token that is comes and applies the spike arrest policy, and which means how many requests can be sent in a second or in a minute, such kind of uh, policy you can apply here. In this example, we have kept like one request per second, which means in 60 seconds you can make 60 calls, but if you are making multiple calls within a second, this will throw error, right? And also I mentioned that you could have different API quotas based on your plan, and this is where sample gives you this option as well, where we have 3 plans and different quota policies applied, right? If you go for standard plan, we have put 1200 API calls per day, right? Then you have premium plan and trial plan. You could have different quotas applied together. So even before it is reaching to your workload, your API, all these policies are validated, and if the policies are violated, then it just throws error. So it's not even sending to your workload. From target endpoint perspective, and this is where to confirm that all these policies are validated and it reached here, and this is where we are creating different that SSN header and passing it, so that the virtual service forwards the request to the CAP workload instead of forwarding back to the API management, right? For that reason, we are creating all the tokens and adding to the header. Also, you could track certain statistics as well, and this is where to showcase that feature as well. We have using this statistics collector policy, etc., and to have some KPIs for your APIs as well. And if I have to show one such KPI that is there as part of this sample, how to design such a KPI, right? We are storing certain information, we're collecting certain statistics. You can see how many calls were made to this endpoint, or which all tenants are making how many calls. Currently just one tenant, so it's just showing one, but if you have multiple tenants, you can see how many calls are being made. So such things could be achieved by integrating API management. In our repo, we not just API management, we talk a lot more service integrations, and the features, integrating to Microsoft Graph, etc. are there. So if you're trying to experience how the deployment and everything looks like, I would recommend that you start with the basic one, try to deploy and trial account, and then move on to the advanced things. When you're building the application. Yeah, that is all I have for today. Now I will hand back to Gaurav.
Thanks, Ajit, for that wonderful walkthrough. There are some questions I saw in the chat which I think Alper has already answered. But yeah, I think the room is open. So the participants, if you have any further questions, you can unmute yourself and post the queries. If not, then as mentioned, the recording would be uploaded to our YouTube channel. Please subscribe to the channel so that you can get the recording as soon as it is uploaded. Let's see. Okay, if there are no further questions, I would again thanks to all the participants. Okay, sure. Thanks, Adi. We will provide the email from Alpa and you can then connect offline. Great. Then thanks, Ajit and Alpa, for your time. Cecily, also for your time as well. And we would be also doing a repeat for this session for the Americas and EMEA friendly time zones. So if you joined late or if your colleagues are based out of that region, feel free to share the episode and sit with them. Thanks again to all of you. Have a good day. Bye.
Thank you, everyone.